Welcome to Coach Taylor's class notes. Today we're going to look at angle congruence and angle addition postulate. So first thing, we talked about this with line segments, but we're going to talk about it again with angles. So congruent angles means that if we're looking at the example to the right, the measure of angle A is equal to the measure of angle B, then the angles are congruent. And the way that we write this is that we write the measure of angle A is congruent, because we use our congruent sign, to the measure of angle B. So again, because both of these say 75, what are you doing, iPad? We know that they are congruent. And the way that we mark congruence as angles is we kind of draw that little semicircle, and that little semicircle tells us that those two angles are congruent. Another concept that we talked about with line segments is we talked about segment bisectors. So a bisector is anything that cuts something in half. So we can have a segment bisector that cuts a line segment in half. We can have an angle bisector that cuts an angle in half. But again, that bisector word and vocab word is cutting it in half. So when we have an angle bisector, it is a ray that divides an angle into two congruent angles. So if we're looking at the picture to the right, ray BD. Now remember, when we name rays, we always start with the endpoint, and then we go out to the arrow, and we use those two lines. That is an angle bisector. BD is. Therefore, we know that the measurement of angle ABD, because again, that's this angle right here, and it's marked by that line segment there, is congruent to angle DBC, which is this half here. And again, those two little half circles tell us that those angles are congruent. We also talked about perpendicular lines earlier, but we're going to just talk about it again and remind ourselves. So perpendicular tells us that two lines that meet at a right angle. Our symbol for perpendicular is an upside down capital T. And what that means is that essentially we know that those two lines meet at a right angle. So that's that upside down T. So if we're looking at the diagram to the right, we know that line L, what are you doing, iPad, is perpendicular to line M. Remember, if they give us this lowercase script, we don't have to use 2 points to name a line. We can just use that lowercase script letter, which is what we're doing in this case right here. And again, we know they're perpendicular because of this right angle marker right here. And so now we're going to combine perpendicular and bisector together. So a bisector cuts something in half, and perpendicular tells us that those two lines meet at a right angle. So our perpendicular bisector is a line segment or ray perpendicular to a segment at its midpoint. So again, bisector means it cuts in half. So if it is a line segment that it cuts in half, we know that wherever that line cuts through is the midpoint, which then would make those two halves congruent to each other. So in the diagram to the right, line LM is the perpendicular bisector to line segment PQ. So PQ does not have arrows on the end, but LM does. So we have to make sure that we are labeling and naming those two things correctly. All right, so now let's talk about one additional rule. We talked about our segment addition postulate. Well, this time we're going to talk about our angle addition postulate. Our angle addition postulate is almost the exact same thing as the segment addition postulate. Now we're just going to talk about angles. So if point D is the interior, so it's inside angle ABC, then what I know is that the measure of angle ABD So let me real quick draw that for you. Angle ABD plus the measure of angle DBC. Again, I'm going to draw that in blue. Equals the measure of angle ABBC. Okay, so the two parts of the angle add up to equal the whole or the entire angle. So now let's real quick look at this first example here. So what we need to do is we need to use our angle addition postulate. So the information tells me that angle MPQR equals 49 degrees. So if I look at PQR, the whole thing is going to equal 49 degrees. And so now I need to look at the parts. So angle PQS is going to be 13x plus 4. And then I know that angle SQR is going to equal 10x minus 1. So those two parts are going to add up to the whole, which is 49 degrees. So now let's combine our like terms. So 13x plus 10x gets me 23x. 4 minus 1 gets me a negative 3, which equals 49. Now I need to go through my equation steps. I'm going to add 3 to both sides. So 23 equals 54. Nope, 52. I can't do simple math. Excuse me real quick. So now we need to divide by 23. I'm going to do some guess and check. So I know that 23 times 2 is going to be 46. Another 23 is going to equal 69. So that's not correct. Give me 1 second. Oh, I know what I did wrong. Sorry, guys. I messed that completely up. That should be a positive 3, which means we need to subtract, which means we get 46. I knew I messed something up. No, wait, that one was still 49. I got to erase the other one. 49. So then we get, come on, eraser. So then we get 46, and 46 divided by 23 we know is 2. And now I need to plug that 2 back into my two angles to figure out what the measure of PQS and SQR is. So 13 times 2 plus 4 gets me 26 plus 4 should be 30 degrees. SQR is 10 times 2 minus 1, so that's 20 minus 1, which should be 19 degrees. And then I know that 30 plus 19 is 49, so we did our math correctly. All right, so let's go ahead and let's keep practicing our conditional statements in the different sections. So our P is our if there is an angle bisector. Our Q is going to be then there are congruent angles. So go ahead and write the inverse, the converse, and the contrapositive. And then I want you to create a counterexample for a perpendicular bisector creates two acute angles. If you want to check these answers, you're more than welcome to look at the completed notes.